everybody. I'm Steve Rowe. I'm going to be talking about schemaless Solr and the Solr schema REST API. A little bit about me. I'm a LucidWorks employee. I've been a Lucene Solr committer since 2010. I've been a committer on a project called JFlex since 2008. It's a scanner generator that's used by Lucene. An example of that is a standard tokenizer. Previously, I was at the Center for Natural Language Processing at Syracuse University's iSchool, also known as the School of Information. So, schemaless Solr. As of version 4.4, Solr can operate in a schemaless mode. There's no need to pre-configure fields in the schema, and in order to populate the schema, you just index documents. Previously unknown fields are automatically added to the schema, and field types for those fields are automatically detected from a limited set of basic types. Those types are the ones you see there: long, double, Boolean, date, and text, which is the default, all of which are multi-valued. So this feature works in standalone Solr and in Solr Cloud. There's three features that I list there over on the right. They're used to implement this schemaless mode: managed schema, which is required in order for the schema to be modified at runtime; field value class guessing, in which parsers attempt to detect the Java class of string-valued field content; and automatic schema field addition, where Java classes of field values are mapped to schema field types. So this is the slide about the nature and utility of schemalessness. There's some debate about use of the term schemaless, and particularly because of that first sentence there. Schemaless does not actually mean that there is no schema, surprisingly enough. So the reason for that is that search applications need schemas in order to support non-trivial document models. The only case where you don't actually need a schema for a search application is if you only have a single field, or if there's only one field type. That is, all fields share processing, including analysis, index features and format, similarity, implementation, etc. So these are the things that Solr allows you to configure for field types, right? For the rest of the search apps, which is basically all real-world ones, they need to manage per-field processing configuration, and that is what a schema is. So in order to consistently index documents and effectively serve queries, you got to have a schema. What schemaless mode does is makes it so that that's behind the scenes, and users beginning to use Solr don't need to know how to do the manual configuration that's otherwise required. You could consider this as a sort of schema discovery. Document structure is either not fixed or it's not fully known. So I would be remiss if I didn't discuss dynamic fields, which is a feature that Solr has had since its first public release, and probably before then as well. Yannick Seeley calls this convention over configuration. Glob-like patterns match field names with field types. So there's an example there from the example schema in which any previously unseen field that has an _i at the end of its name is mapped to the int field type. So dynamic fields solve the problem of assigning field types to unknown fields by inferring a field's type from its name. And by contrast, this new schemaless mode infers a field type for an unknown field from its value or its values. And these are not, these approaches can coexist, are complementary. And in fact, the schemaless example that ships with 4.4 and later defines a number of dynamic fields, including the one that you see there. So I'm going to walk through an example of indexing an example set of documents in a CSV file that comes with the Solr binary distribution, the books.csv file. There's a new example directory that comes with Solr now called example-schemaless. And from its schema.xml, you can see there the only two fields that are predefined. This is in stark contrast to other examples that come with Solr, which have many predefined fields. So the books.csv has all these fields in here. I've highlighted or emboldened, I guess, the fields that are not already defined in the schema. So ID is there. Version, which is a requirement for Solr Cloud, isn't listed here, but these other ones are _T_I_S at the end are meant to match against dynamic fields. So these other 5 fields are not in the schema, and depending upon the way Solr is configured, if you tried to index documents before schemaless mode with fields that weren't already in the schema, you could either get an error or it would just drop them on the floor. So in order to start in this new schemaless mode, if you go to the example directory in the unpack binary distribution and start.jar pointing Solr home at the example schemaless Solr directory, and then post, using the simple post tool, the books.csv file. That will index all of those and run through the process of figuring out which fields aren't already in the schema, detecting their types, and then adding those fields to the schema. Later on, I'll talk about the schema REST API. At the top there, the curl call uses the schema fields API method to get back all of the defined fields. This excludes dynamic fields, that particular call. And I've except for the response header, which I've left out here, and reformatting white space, this is the entire response there, and I've aligned it so that you can see field names and field types for the stuff that gets returned. So the stuff in the different colors than gray are the ones that have been auto-detected. So author, cat, and name were not detected as either the 2 numeric types or as Boolean or as date. So they were given the default field type of text general here, and I'll show where that gets configured later on. But you can see here the field type definitions that come with the schemaless example. So Booleans and T-doubles for the in-stock and the price fields. So I've reformatted the books.csv as a table here. Price, you can see, is a float, and so gets detected as this double multivariate. That's what the XS refers to. Field type, and let's see, in stock because its value is false, gets detected as a multivariate Boolean. Next I'm going to walk through those 3 features that I was talking about, which together comprise schemaless mode. The managed schema is the first of those 3. With managed schema, which, as I said previously, is a requirement for runtime modification of the schema via Solr, Solr manages it rather than being hand-edited. So on first startup, if managed schema doesn't exist, the schema.xml is automatically converted from from standard format to managed schema. So here's the stanza from solrconfig.xml. You can configure the name that the resource will have either on disk for standalone mode or in Zookeeper here. And in order to allow for modification of the schema, you have to set this mutable setting to true. Currently, the format of this managed schema file is XML, but that could change in the future. So it's nice to be able to read it, but its intent is not enabling, or at least its first priority is not enabling human legibility, but rather making it possible for the system to interact with the file and make modifications. So in particular, if you go in there and hand edit it while it's in mutable managed mode, your changes could be overridden. So while I say at the top there it's managed by Solr, there isn't anything stopping you from making modifications to the file on disk, but your changes won't be respected. One negative about this is, at least at present, XML comments don't survive the conversion. I'll talk about a proposal I have at the end of the talk to add schema annotations to the managed schema implementation so that documentation and user metadata can be associated. But that currently doesn't exist at this point. So runtime schema modification at this point is used by this feature that's required for Schemaless Mode, the automatic schema field addition, which I'll be talking about a little bit later, and for use of the schema REST API. So both of these use the same back-end feature that allows for runtime schema modification. So this is just a listing of the configuration directory before startup when you've enabled the managed schema mode here in solrconfig.xml. So initially a schema.xml file exists. Then it gets renamed with .back, and the converted file managed schema is in its place. This is awfully small. I hope people can see it. The second of the three features that are required for Schemaless Mode is what I call field value class guessing, in which unknown fields' string valued types are speculatively parsed. So that this bit about the type of fields is significant because, for example, if you submit a document in JSON format, the JSON parser is capable of detecting the types of those fields from roughly the same set of simple types that the Schemaless Mode is capable of detecting. So field value class guessing isn't required because they are not represented as string value types, or at least for those types such as floats and integers that JSON is capable of parsing and providing a type for. Dates are not among those, so if you submit a date using a JSON format for a new document in a field that's not already in the schema, then it will be doing the field value class guessing for it. So what happens is there's a cascading set of parsers that attempt to recognize field values. So in this configuration you can see here, this happens as part of the standard update request processor scheme. There's in solr.xml there's this chain that I call here add unknown fields to the schema that gets set as the default, and it gets run through that for each field value. So in this pre-configured set, blank fields are removed so that they don't throw off field type detection. And then each of Boolean long, double, and date parsers attempt to parse field values. And if they fail, it just goes on to the next one. If they succeed, then that's assigned as the type. Let's see. So I should probably mention here that this is Runtime syntax for date formats, and you can reconfigure that to accept dates in whatever format Runtime supports, which can be useful because Solr's date recognition is fairly limited, but Runtime is quite expressive. So if you have dates that you can't convert to other formats easily, this is something that you can use independently of Schemaless Mode to do date detection and apply a date type so that it gets recognized as such. So these are, I talk a little bit about how these are reconfigurable. In addition to being reconfigurable in Schemaless Mode, as I just mentioned, these processors are usable outside of Schemaless Mode to do parsing in various ways. One of the different configurations that are possible is swapping out integer for longs. So here there's only the wider long field detection that occurs here. But if you're interested in reducing disk space for those, you can swap it out for a narrower type. Another possibility is supplying a locale to use for the number format parsers that are used for the numbers here. So that if, for example, you want to be able to detect floating point numbers in some European countries use, for example, commas instead of periods for decimal places. And those can be, if you apply a locale or supply a locale to for example, the double field update processor, it can parse those directly instead of having to convert them first into sort of a standard floating point format. Similarly, the date parser can take a locale and a default time zone. So the final of the three features that comprise Schemaless Mode is this automatic schema field addition. Field value classes are mapped to field types. So you can see over here in each one of these type mappings, which are applied in the order that they're specified. When the system, so I didn't say this, but this is just a continuation of the same update request processor chain. It's just the final processor before the distributed and the log update processors. So as I was saying, the type mappings are applied in sequence. So if it sees a field value with type Boolean, then the Boolean's field type gets applied to it. And the first match wins. If none of them match, then the default field type that's specified here is assigned. For multi-valued fields, it's possible that you get a document in that has other processing applied to it, or say a JSON document that has a field with multiple values, one of which is specified as a string but is really numeric content, for example, and the other is, say, an integer. So you would arrive at this point, or you potentially could arrive at this point with a field that has values with different types. The system is possible. It's possible to configure that so that multiple types map, multiple value classes rather map to the same field type. So in this case, if a field has multiple values and arrives at this point, one of them integer and the other one long, then that field will be created in the schema as this t-longs field type. So as I say here, this is reconfigurable. If you decide that you don't want to use dates, or you have other field types that you want to map these things to, this configuration can be modified. So there are some limitations to this schemaless mode. Using this feature in production is probably not a terribly great idea. I think there might be some cases, for example, multi-tenancy, where the people who use your service don't know their document formats in advance, or you don't have a system for them to communicate to you what those are. In that case, I guess it's possible that you could work out a system where if they didn't need a varied or tightly specified analysis regime, for example, that might work out. But I think in most cases, this schemaless mode is probably best used as just an exploration tool. Here's an example of a problem that could occur in production that you don't want. If the source of your documents are produced in a way that human error, for example, could introduce a typo, no error will be produced. Instead, you get these bogus fields that get produced, and documents won't have the structure that you expect them to have. And there's no way to know about that unless you apply some, say, auditing tool or something like that to go and see that there are no fields that you don't expect. Another problem that schemaless mode has is that it only looks at the first instance that an unknown field occurs in order to detect the type. So the standard example that I use for this is if a numeric field shows up and has an instance that looks like an integer, and the next document has a non-integral number type, a floating point type, then that'll trigger an error because the integer field has already been added to the schema, and you arrive with a document that has a floating point type. So the way the field type detection works, the system can't know about the full range of a field's values, and so the decision has what could be overly limited information. I talked about this before earlier, that you can waste space because the example for schemaless mode is conservative. It assumes if you have integers, you want to provide the largest space available, where integers might suffice. Another problem is the limited gamut of detectable field types. So I think the standard example comes with Solr has something like, I don't know, 40 different field types, and there are only like 5 that are associated with the schemaless example. So that could be quite limiting. Also for these other two reasons, that the text fields only have a single analysis specification. There's no string type. For example, you can't just say, take this entire field, regardless of whether it has spaces or punctuation or whatever, and treat it as a single token. Similarly for other processing for all fields. So there's this search solved tweet request here. I'm going to transition now to talking about the Schema REST API. Does anybody have any questions about schemaless mode? While I'm thinking about it, I've been asked to request that you use the Revolution app to fill out surveys for the conference and for each of the talks that you've been to. We'd appreciate that. So the Schema REST API is relatively new, introduced I think first in 4.2 in a couple of small ways. The schema is covered, all aspects of it are covered for read-only purposes, and a couple of different modifications are possible now, but not all aspects of the schema are modifiable at runtime at this point, but work is in progress to enable that. The read-only aspects of the Schema REST API can be supports output format of either JSON or XML, and you can specify that as the WT request param. The default output format is JSON. And you can get this set of things for the schema, the entire thing, the entire schema. You can also get it in standard schema.xml format using this schema.xml WT param. You can get all the fields or a specified set of them, all dynamic fields or a specified set, all field types or a specific one, all copy field directives, and all of these small pieces of information: the schema name, version, unique key, default query operator, and the global similarity. Using the read-only aspects of the Schema REST API doesn't require managed schema to be turned on. By contrast, any modification of the schema via the Schema REST API does require managed schema to be turned on and mutable set to true. So here's a couple of examples for a couple things that the read-only API can do. If you request the *_i dynamic field, you get this response by default in JSON, as I said before, where it tells you the name, type, indexed, and stored. I don't show it here, but there's a parameter you can specify that shows the full list of attributes that are associated with dynamic fields and fields too. This just shows the ones that are explicitly specified. So this is just XML format for unique key. One thing that maybe is not obvious, but when I was setting up the URLs for the different elements of the schema, I made all of them downcased, and in the response, the same casing as in schema.xml. So unique key in schema.xml has a uppercase K, but to be consistent in URLs, the entire name for things is downcased. And there's a link there to the Schema API section of the Solr reference guide, which has full details on all calls that are possible. For runtime schema modification, as I mentioned, you have to have managed schema facility turned on, and it must be configured as mutable. as of Solr 4.4, there are 2 supported modifications, adding fields. When you add fields, you can optionally add copy field targets for those fields. And separately, copy field directives can be added. These features work under both Solr standalone and Solr Cloud. Under Solr Cloud, a form of optimistic concurrency detects simultaneous requests and automatically retries if those requests conflict. These modifications that have been added so far don't require core or collection reloads, but other forms of modification which could result in conflicts or conflicts with already indexed documents will require a core reload. Generally, additions are not sources of schema incompatibility, or at least as far as I can think of. And so, as a result, for these additions, and also for addition of things like dynamic fields, it shouldn't be necessary to do core or collection reloads. But for these other things, it will. So modifying or removing dynamic fields or copy field directives, or modifying all the other schema elements, reloads will be necessary. So here's an example of adding a field using curl. Individual fields, when they're added, use the rest put verb, and you have to specify the content type. So in this case, I'm sending in a JSON request to add a field named claim ID of type string that's stored and has these 2 copy field targets. When you specify copy field destinations, they have to already exist in the schema or the request will fail. So again, for full details, you can see the Solr reference guide section that's linked there. So the Schema REST API is still a work in progress, and here's a list of things that still are left to be done. Solr 4898 is the umbrella JIRA under which this work will be done. That includes adding dynamic fields, adding field types, enabling whole serial replacement by putting a new schema, modifying and removing fields, dynamic fields, field types, and copy field directives, and modifying all remaining aspects of the schema, including name, version, unique key, global similarity, and default query operator. So this is the last section of the talk. I made a proposal to the Solr development list about something that I'm calling schema annotations, which would add arbitrary metadata at the top level of the schema and at each leaf node, and would be writable and readable via the REST API. So I think this would solve the problem of the XML comments being stripped from schema.xml when conversion to managed schema occurs, and would enable round-trippable documentation in general. Would allow for tagging elements of the schema which could be documented in a central location, and for example, could allow for, say, a last modified annotation to be automatically added when modifications were performed. On the Solr user mailing list, there were a couple of people who expressed alarm when schema parsing was tightened so that unrecognized fields caused parsing errors. What they were doing is that they were putting their own information on schema fields and field types, and then using that for their own purposes, but when schema parsing was tightened, I think in 4.4 or 4.5, that was no longer possible. Such a feature, schema annotations, would allow for people to put in arbitrary metadata that would be maintained and wouldn't be lost on rewriting the schema by the system under managed schema mode. The W3C XML schema has a similar facility, and I give a link there to that facility. So this is just an example of the sort of thing I'm thinking of for annotations at the top level. So at the top level, a description for an annotation called tag that has this name, plain numeric field types. So this is a sort of a spelled out documentation for a tag annotation that tells what it's about. So if you look over here, for a field type, there's a tag annotation that has the same name in multiple places. So this would allow for sort of a compact annotation that could be fully spelled out elsewhere. This is sort of a documentation replacement for all of the comments that are in Schema XML right now. So if you look at the example, a schema, it's probably 3/4 comments that are commented out alternatives or description of different features. These could be re-expressed as documentation that are associated with particular things like copy field here. And there's the last modified tag that I had mentioned as a possibility for use for this kind of annotation scheme. So in summary, Schemaless Solr allows quick prototyping with minimal setup. Not a good idea for production under most cases. Schema REST API provides programmatic read-write access to the schema. There are only a couple of elements that are writable now, but soon others will be. And my proposal for schema annotations could fix problems with the managed schema dropping of XML comments and allow for tagging and arbitrary user-provided metadata. And that's it. Any questions? So the question is, when is it necessary to re-index after you've made modifications to the schema? I think the safest thing is whenever you make a modification to the schema, re-indexing is the thing to do. I think one major use case for this is sort of scripted startup from scratch, in which case there's nothing to re-index because you haven't started yet. And in that case, all indexing will occur after you've completed a set of modifications. So I'm talking about the Schema REST API. For Schemaless Mode, there's no, it's only adding new fields, and theoretically, those new fields shouldn't conflict with existing indexed documents. And as I said in the talk, I think it's the case that additions to the schema, as opposed to modifications or deletions, shouldn't produce documents and a schema that conflicts with existing indexed documents. Like I said, the safest thing is just, if you have documents indexed, to re-index after you've modified the schema. But for when you're adding fields or dynamic fields, probably also copy fields, it's probably safe not to re-index. But you'd have to evaluate that to make sure that there isn't some problem that I'm not thinking of. Does that answer your question? Okay. Thank you very much.